Fundamental Theorem of Arithmetic have many applications. You have applied Fundamental Theorem of Arithmetic in your earlier classes without actually knowing that it was Fundamental Theorem of Arithmetic. Remember how you used to calculate HCF and LCM using prime factorization method? That was nothing but application of Fundamental Theorem of Arithmetic. Let's quickly revise how to calculate HCF and LCM using prime factorization method. Let's quickly try to find the LCM and HCF of numbers 72 and 120. So how do we go about it? Let's first try to find the HCF of 72 and 120. So what's the first step? The first step is to prime factorize these numbers. Once you have prime factorized, you have to write these prime factors in powers. So that's your second step. Once you have done that, you have to observe these numbers closely. Look for the common prime factors in each of these numbers. We can easily see that 2 and 3 are the common prime factors in both 72 and 120. And what do you do next? You take the smallest power of these common prime factors. For 2, you can see that there is 2 cube in both 72 and 120. So you take out 2 cube. For 3, you can see that 3 power 1 is the smallest power of the common prime factors. So you take out 3 power 1. Now the product of these values that you have taken out, that is 2 cube into 3 power 1, will be the HCF. And what is that? 2 cube is 8. So 8 times 3 is 24. So there you go, you just found out the HCF of 72 and 120 as 24. Now how do you find the LCM of these two numbers? For LCM, you just not consider only the common prime factors. You have to consider all the prime factors that is involved in these numbers. So when we look at these numbers, we can see that 2, 3 and 5 are the prime factors that is involved in these numbers. So what's the next step? You have to look for the greatest power of these prime factors. For 2, the greatest power is 2 cube. For 3, the greatest power is 3 square. And for 5, the greatest power is 5 power 1. The product of all these will give you the LCM. And what is that? So 2 cube into 3 square into 5 will give you the result as 360. This means LCM of 72 and 120 is 360. So that's how you find LCM and HCF of any two numbers. That was basically the review of what you have already learned in your previous grades. We just tried to connect it with the Fundamental Theorem of Arithmetic. Now notice something important here. Let's try to find out the product of LCM and HCF that we got here. When we do that, we will get the result as 8640. Now interestingly, this is same as the product of the actual numbers itself. That is, when you multiply 120 by 72, you will get the result as 8640. Now isn't that interesting? In general, we can say that for any two numbers A and B, LCM of A and B into HCF of A and B will be equal to A into B. Now this is true for any two numbers. If you have three numbers, this method will not work. So for any two numbers, if HCF is given to you, you can easily find the LCM or vice versa. Consider this simple example. LCM of two numbers is given as 36. And HCF of two numbers is given as 18. Can you find the product of these two numbers? Simple. We just discussed that the product of LCM and HCF of any two numbers will be equal to the product of these two numbers. So what was the LCM? LCM was 36. What was the HCF? It was 18. So if you just multiply these two, that is 36 into 18, which is 864. This itself will be the product of the numbers. So that's where you apply this rule. Just like that, if product of the two numbers is given to you and either one of the HCF or LCM is given to you, you could be able to find the other one. That is, if the product of two numbers and LCM is given to you, then you will be easily able to find the HCF. If product of two numbers and HCF is given to you, you will be able to find the LCM. That's it. So that's how we apply this rule here.